Hello, and thanks for watching. This video is a technical video just to show you what I've done in a bit more detail with the refrigerator power supply. The refrigerator in this unit is an 8 cubic foot Dometic 120/propane fridge. There is no built-in capability to operate this fridge with 12 volts DC. I ran for years with my gas on while I drove the RV, and then I became aware that this was a bit contentious, and that if, whether it's road vibrations or an accident, that if you have a leak, it'll get awfully lonely and then it'll get awfully exciting, and that perhaps as a responsible RVer it'd be better to run the propane off with the shut off at the tank. Now the tank shut off on this particular RV is a manual valve at the tank, so you can't do this while you're driving. So the idea, of course, first would be simply just to close the door and leave it shut. My experience has been that the refrigerator in typical summer temperatures, especially in the United States, will lose substantial temperatures during the day. It would be, let's say, in 2 hours, it would go from 5°C to 15°C. So that's going up in the neighborhood of 20 odd Fahrenheit degrees in that time, which is unacceptable. So that's left with that reality. So what I decided to do, I had an inverter in the vehicle, which was rated at 400 watts. I did some tests and I found that the fridge was drawing about 330 watts of power. So at 120 volts we're looking at about 3 amps, maybe just a touch under. And that with the 12 volt case, that's going to be 28 amps or something to that effect off the batteries. So what I thought of doing was to set up a switching system so that I could choose the 120 supply that I would use to run the refrigerator. I could use the ground power if I'm attached to campground or whatever, or I could use the 120 volts from the inverter. Now, with most refrigerators, the plug to connect the refrigerator to the 120 is in behind the fridge. It's accessible just from the external access panel. It is certainly not something you can do while you're driving, where you can simply switch the plug from one outlet to the other, for example. So this led me to something that I wanted to be able to do while I was driving or at the console up front, one way or the other. And so what I decided to do was originally I got a bus transfer switch. I think I can do it now with a toggle switch, a 3-way toggle switch, but for now that's what we're doing. And the idea being that we use electrical switches known as relays. And so what happens is you use 12 volts to tell the switch to actuate the switch. So the 12 volts off your battery, so you run fairly light wire up to the driving console. That's part of the switch, and then you run it underneath whatever to the near the area near the refrigerator, and then depending on the setting of the big switch, it will turn on whichever switch you want. And so what this does is energizes either the supply from the inverter or the supply from the ground. You also have a third position, an off position if you will, which of course is the position you would use if you're using the propane. The refrigerator is generally an automatic setting, and if there's electrical power available, it will use that over the propane by default. Although we can force it to use gas, as we sometimes do. So this is the plan I had. So I had purchased a couple of relays and so forth, and it worked pretty well initially. One of them failed. I got another set. They worked really well for a while, but recently the one that I use when I'm driving, the one that's connected to the inverter, has failed. And I got the idea that I thought I understood why the failure had occurred. The relays were taped down so that they weren't coming loose. But what I think was happening was the vibrations as we drive down the road. On a smooth highway, perhaps it's not too bad, but anyone who's RV'd for a while knows that that doesn't happen all that often. This is a gas pushing 19-year-old unit, and so of course the springs and so on, even though with new shocks, you're still going to get a fair amount of road vibration. So what I think happening was that the contacts were chattering a little, just micro chattering, and the 120 volts would be arcing across, and this would create carbon deposits and other things that really create resistance. So even when they were engaged, you're not getting the full flow. So I had to move then to a vibrationless type relay for the auxiliary one only. The gas one, or the GSE one, is running out of the house power, and that would be only when we're plugged in. Now technically that could run off the generator. Right now this unit doesn't have a functioning generator, so we're not too worried about it just now. If the generator were to get fixed or something, then we might have to move to solid state with that as well. So anyhow, that's been the repair today, was to change out the auxiliary relay with the solid state one, the one that doesn't have a physical part that is not susceptible to vibration, and it's meant for motor controllers, which is an appropriate one for this. So I've mounted these relays. Is very convenient. Let me show you just a second here. Of course, these are fairly small devices, but this is the mechanical relay. You can see the contacts and so on in here, and you can see the pins coming out the bottom here that make the connections to your wires. And if you had to solder onto these, it would be a little bit of a pain, and of course with 120 volts, things are pretty close here. It gets a little bit exciting. But the nice part is that they have a what we call a track module. And this is one of the example of one here. So you can insert, I get it right, the relay into the track module. I don't know why this one doesn't seem to marry up, but whatever. Oh, I see. Now, so you can insert this into the track module, and then the connections can be made with the standard screws, so you can put your wires into these and tie them down. It's a wonderful system, and so that's been really good. These are the solid state relays, so it's a enclosed package. Now these are only going to switch, this one switches 2 wires at the same time. We call a double pull, double throw relay. This one is a single pull, single throw relay. It makes one connection. It's either off or on. This one here is on or on, depending on which pole you switch to. I didn't need that much, but that's the kind I was able to get. So in this case, we're going to be switching one wire of the 2. So I have 2 of them, and this will switch the other wire. And I'm just being super careful when I run this that I'll switch both wires, because with 120 I don't want any excitement. And these connections here are for the coil, in quotations, from the signal up at the driver area, driving console. And so what I've done is I've wired these in parallel, so they should go down at the same time. Amount of current driving these is incidental. So what happens is, I'll show you in a moment here, is that these will be also mounted in their own track module, and we've screwed it all down here. I'll give you a little tour of that, and then comes the big exciting moment of commissioning to see if all of this actually works as advertised. Right now all the power's off, so we'll have to wait and see, but everything looks like it's supposed to. So we'll move down to the actual site so you can see the tour. We'll see you in a minute. So we'll just take a little pan of the RV. So here's the kitchen, and there's the refrigerator. So all of the circuitry I'm doing is in this console here underneath the refrigerator. Okay, so this first black item here is the track for the ground. That's still a double pole, and then the 2 twin ones, this is one, that's the other. These where the solid state relays will go here, and thankfully there's a clamp so I don't have to tape them down. Now what we have then is, here's the supply. Let's back it out. There we go. This wire here is the supply if it's connected to the generator or the house. This is the power going to the refrigerator, and the blue wire down here that loops around is the feed from the inverter. So what happens then is we have the grounds connected, so as the feed comes in, the auxiliary one will go to these two solid state ones. If these wires here are live, that will make the connection. You'll be energized over to here. This sends energy to the refrigerator. If I choose the front one, when we're in ground connected to the shore power, these two will not be connected, and the power will come from this one and right through to the refrigerator. If I don't select either, nothing is connected, and the refrigerator is either off or must be operated with propane gas. So that's the plan. You can see the relays will go into the units with quite easily. You simply push the notch back and just simply set it in until it snaps in place. And the connectors are indexed, so you can't do it wrong. Otherwise it just won't fit. So here we are. Those are now connected. And then we have the ground one here. So just pull back the tape and get my indexing correct here. Yeah. So it goes on like so. And there it is. And we'll tape it down. And now, theoretically, we are ready to go. When the coil is selected, you will get a red light on this relay or on the two of these, depending on which coil is engaged. So we'll have to see now if things work out as they're supposed to. So the relays are in place, and the 12-volt power on the RV's main system has been energized. Currently the selector at the driving console is off. I'm going to first choose the GSE ground support equipment selector. So the first relay covered with the gray tape will come on. You should see a red light through the tape. I'll leave that for about 5 seconds, and I'll switch it to the auxiliary setting. That should then turn on the lights here on the two solid state relays. So let's see what happens. So switched on the power, and there you can see the red glow for the relay for the ground power. So that's actuated, and you can see that the other set are not engaged. Now switch to auxiliary, and you can see that the red light has gone off and the two solid state relays have engaged. So this is a fine test to this. It seems to be working. And so now what we'll do is we will now engage the inverter circuit and see if we can get power made for that, if possible. So what's happened now is the inverter circuit is energized. The refrigerator's been turned on. It's trying to run propane because it has no power just now. And we'll just let that cycle a bit here. And now I'm going to turn on the GSE switch at the driving console and see if we can get the current draw that shows that it's actually flowing. Right now it's about 1.5 amps. The fridge may still be looking for propane. might take a few seconds for it to see. Okay, we still don't have the switch made. Oh, I know why. Stand by one. Didn't have the line plugged in. Now, let's see what we got with current. Okay, there it goes. Okay, so we've made the connection with the inverter through the relays. Seems to be working fine. And of course you can't tell or hear anything except that the two green lights are on, indicating that they've been selected. The refrigerator's gone on fault, which indicates it can't find the propane, and now it's working on the inverter. The current draw off the batteries is approximately 27.5 amps, which is exactly what we would like. So I'm very pleased so far how this is going. We're going to let this work for a little while before we place the covers. But everything inside is all screwed down. This is the switch I use on the console to select either ground support, which is the house, LPG, which is gas, or auxiliary, which is the inverter. So this is on the console. So as I pull back now, you can see where I'm drive the unit. I can reach that and control it as I go. This is my Victron monitor here. That's the current that the fridge is using, about 27 amps, maybe 25, given there's a couple amps of running anyway, and working very well. So this is just the way it's supposed to operate, so very pleased. So that's my story about the fridge system, and knock on wood, it seems to be working great. It has worked great all summer. The only real change I made is replacing the mechanical relay with a solid state one to reduce the effects of vibration. And this allows me then to go down the road with the propane off and still run the fridge. This is a 8 cubic foot. If I had a 12, it might be a little bit more in current because of the bigger unit, but I don't expect it to be significantly more. And with a decent inverter, I just bought an Ames 600 watt pure sine wave inverter, and it just looks so much more professional than the stuff you find in the stores, and I'm pretty pleased. It only cost me a couple $100 from Walmart, so I'm pretty satisfied with that. And that's of course a really clean supply, which will certainly help things. So that's the fridge story. Thank you for watching, and see you down the road.